Doing good. I was just plugging in my computer before it died.
Sure.
That's the last thing I want before this.
Let's see.
Are we just finishing up the worksheet number 3?
Yes. And also going to just pick out some problems, some random problems from the textbook as well.
All right.
But maybe we can start with number 5. I didn't get a chance to do this in full in class. So this is off worksheet 3. First derivative test. And then I'm going to pick out a problem for second derivative test. And then actually, let's do this. Let's do a first derivative test for 5. And we'll also do a second derivative test using this function as well.
All right.
Okay. So we want to find relative max, relative min, increase, decrease. All that's going to come from f prime. Okay, are we okay so far? These are potential max and mins. And now we just want to know how the graph looks around those points. I'm going to test my test. Going to use these test points with the factored form of my derivative. So -3 and for x, I get negative times negative, which is positive. Okay. Plug 0 in for x, I get positive times negative, which is negative. And plug 2 in, I get positive times positive, which is positive. So what do we know here? What do you expect out of -2? Relative max, right? Relative min, increases here and decreasing here. On the quiz, you don't have to provide the y values. You can just say at x equals -2, or you can just have parentheses, just fill in the x value, and that's it. That's it. Because statements for max, min, and for increase and decrease. So this should be easy because you're just pulling information from your slope sine line, and we don't use the test points after we determine the sign. Okay? Do not include the test points in your intervals. Okay, how are we doing? Are we okay with first derivative test?
You said it was okay if we just leave it at like the parentheses with just the x value, correct?
Yeah. Or I can say relative max at x equals -2. That's fine as well.
Okay.
All right, Julia, Caitlin, you guys okay?
Yep.
So let's do this. Let's take this exact same function and let's see if we can confirm whether these are relative max, relative min using the second derivative test. Okay, so same function. I'll call this 4b, second derivative test. We should get the same result. So from f prime, we got our critical points. We're going to go ahead and find f double prime. Which is 12x plus 6. His faithful sidekick. Ooh, okay, and then we can take our critical points and put it into f double prime, right? And that should also help confirm whether these are max and mins. So what is that? What does the -18 tell us? What do you guys think? How is this information helpful to us? Okay, this tells us about concavity, right? What does this tell us? Concave. Right, it's negative, so concave down, right? If our graph is concave down, that means it looks like this. The only critical point that we see on the concave down graph is the relative max. So we can say relative max at x equals -2. And this matches with what information we were able to accomplish from first derivative test, right? Relative max okay, so let's confirm what's happening at 1. Plug 1 into the second derivative function. (12 plus 6, 18). Positive number. So positive second derivative means concave up. Concave up looks like this. The only point that we see that has a slope of 0 is a point that looks like a relative minimum. And this matches the result that we got first derivative test, right? Okay, Julia, does that help?
Yes, thank you.
Okay. I'm going to do another version of second derivative test. I'll call this 4C. And I'm just going to give you a series of ordered pairs and derivative and second derivative value and see if you can conclude what's happening there. So what conclusion can we make about this point? All right. So this is telling us that we have a slope 0, right? This is telling us that we have concave up because it's positive. So the only way that a graph can look if it's 0 slope and concave up is if our graph looks like this. Slope 0, concave up. This point must be a relative minimum. So this is another variation of the second derivative test. All right, are we okay there? All right. Let's see. Let's see. Okay, how about mean value theorem here? I got a problem from the textbook. All right, so let's go through our conditions. Continuity. We look at our denominator there. There is a vertical asymptote at x equals 0. But we see that 0 is not going to impact our interval, so we're safe. Our function is continuous and differentiable. And now we can focus our attention on the formula. So no derivative just yet. Let's focus our attention on trying to get to the slope. So we take our order pair, or take our endpoints, x value, plug it into the function, and find those order pairs. Take our order pair, find the slope, and then we can decide what goes in here. think that reduces to be just -1/4, right? So we have this piece figured out. Now we just have to figure out what f prime is. So f prime, we could go through quotient rule, but if I just bring that x up to the top, I think power rule can be a little faster. So if I think of f of x as x to the -1, right, maybe it's easier to just go through power rule starting with x to the -1. So f prime, -1x to the -2. Which if we clean this up is -1 over x squared. So we have the two pieces that we're going to set equal to each other. We have our slope, we have our slope formula. If we set them equal to each other, we can figure out where on this curve is there a slope of -1/4. And if I solve for x, I can find the location of this slope. Okay, cross multiply. So we're guaranteed at least one solution, but are we going to keep both of these solutions? Or are we going to keep both of these locations as solutions? What do you guys think?
No, because one of them is not between the interval.
Right. -2 does not fall inside between 1 and 4. Only 2 does. So you have to get one solution. If you don't get one solution, you got to go back and check. But we can't just blindly keep every solution that we find. Okay, so there's an example of mean value theorem. Okay, any questions? Okay, so you guys need to let me know what you want to see. Daniel, do you have anything that you need to see or need to go over?
Let me check.
Julia, what else did you want to see? I think we did a first derivative test, we did a second derivative test, we did the mean value theorem.
I think that was it for me. Thank you.
Okay. Hey, Ethan, you have any types of problems you want me to go over with you?
Hold on. I need to get my workout.
Okay.
I think I would just need like one Rolle's theorem problem.
Okay. All right, let me see here.
Mr. Yang,
Yeah.
can you do a Rolle's theorem problem?
Yeah. I'm looking for one here. Two. Okay, let's see if this works out. Okay, Rolle's theorem. This is from the textbook here, number 24. So we have three conditions for Rolle's theorem, right? First is continuous, second is differentiable. Front office? Yeah. Yay, I'm so sorry. I should have got it earlier. Okay. Yeah, I know, I will. See ya. All right, Rolle's theorem. Continuous, no issues with discontinuity. There's no denominator to worry about. And we're going to get a smooth curve all the way through. So we're good here, okay? So our function is continuous. Our function is differentiable. Now there's a third condition. Do you guys remember? What is that third condition that we have to be aware of that we didn't have to worry about with mean value theorem?
The endpoints have to have the same value.
Yeah, endpoints have to have the same y value. So it's similar to mean value theorem in the sense that we're going to find ordered pairs as our next step, right? Whether it's Rolle's theorem or mean value theorem, we're going to find the ordered pairs. It's just that with Rolle's theorem, we do need these to be the same number. Mean value theorem, it doesn't have to be the same number. Okay, so I plug 0 in for x. I get, if I plug 1 in for x, I get 1 minus 1, which is 0. So because of this, we know that our slope is 0, right? Not because this is 0, but because if we were to find slope, it's going to be 0 minus 0 over 1 minus 0, which is 0. So I want us to understand that it's not because these are 0 that that's 0. It's because that these are the same. That's what's causing that to be 0. Okay. And because of this, we know that we can guarantee a slope 0. We can set f prime, find f prime, and set it equal to 0. Okay, are we good with this process here? I think what I see students make mistakes with is, let's say these were both 7s. Okay. This is still a slope of what? Still a slope of 0, right? So we're still guaranteeing a slope of 0. We're not guaranteeing a slope of 7 because these are 7s. Right? They're still directly across from each other. They're still giving us a slope of 0. So with Rolle's theorem, we're trying to guarantee a slope of 7. We're not trying to guarantee a slope of whatever this number is. It's just that with 0, it just so happens to be a coincidence between this number and this number. But if these numbers are the same, it'll still work out to be 0. Slope is still 0. All right, so next we're going to find f prime. We go through power rule. And we set f prime equal to 0. Now this one's a little messier because we probably need to get this down to 1 fraction before we can look at the numerator of the f prime. So let's find common denominators. Balance each of the fractions. This one is completely missing anything in the denominator, so I need to balance this with 3x to the 2/3. Okay, with Rolle's theorem, we only care about the numerator, so we're setting the numerator equal to 0. And then we solve for x. Yeah, and that's just some decimal number. Or you can clean it up, make it 3 cubed is 27, square root of 27. Either way, it's a really small number, but it is still a number that falls nicely between our interval, right? It's greater than 0, but less than 1. Okay. Lies nicely inside our interval. So notice with Rolle's theorem, we're only setting the numerator equal to 0 because we only care about slope 0. We just want to know where something like this occurs on the graph. We don't really care about where the slope is undefined. We want to know where the slope is 0. So that's only going to come from the numerator of our derivative. Okay, any questions about the steps involved for Rolle's theorem? Okay, you guys good with extreme value theorem?
Can you move the paper down again real quick?
Oh, yeah.
If we didn't put 1 over square root of 27, would that also be right?
Yeah, either any of these are okay.
Okay.
Guys okay with sketching graphs? All right, what else? In class, we did critical points. Extreme value theorem, you find f prime from numerator and denominator. Make sure that they fall inside the interval. Test those points along with the endpoints. Compare the y values. Highest y value is max, lowest is minimum. We just got done with Rolle's and mean value theorem. All right, Ethan, Daniel, anything else?
Can you do a mean value theorem problem?
Yeah. So here's another one. Okay, I'll choose this one here, mean value theorem, number 40 from the textbook. Okay, so mean value theorem, we need to establish that our conditions are good, continuous, yes, differentiable, yes. So now we move on to mean value theorem, which is, here's our formula. So we know these are good. So we're ready for this. So Ethan, any idea where we can start with this process here?
No.
Yeah, there's something that we're going to do on the right side here. We're not going to focus on the derivative just yet. We're going to focus on this right side. So what is this asking for us to find?
I don't know.
Okay, so let's say these are A and B values. Okay. What does this mean to find f of A and f of B?
To find where the like where y is at that point.
Yeah, that's it. Just find the y values. Yeah. So how would you find the y values?
You plug them in.
Plug them in. Yeah. And after you find the y values, what is this formula telling us to find?
The slope.
That's right, slope. So that's your first step. Okay. Stay away from the derivative just for now, right? Let's focus our attention on finding slope. And then once we know our numeric slope value, then we can find the derivative and then we can set them equal to each other. Okay, so we have our ordered pair. What's the slope going to be? Okay, Ethan or Daniel, what's the slope going to be here?
Would that be 0?
Yeah. So change in y over change in x. So we could call this Rolle's theorem, but this is also mean value theorem. It's just one specific version of mean value theorem. Okay, what's next? We have this number. Now we can find the derivative, right? All right, what's our derivative?
Four x cubed minus 8.
So we have everything that we need for our formula, right? We have the slope, we have the derivative, we'll set them equal to each other. And when we solve for x, we're able to find a location on this curve where there's a slope of 0. Okay, solve for x. So our graph looks something like this. And what we found here was we're able to locate where that slope is 0. All right. How do you guys feel? Any other questions?
What are the types of problems that are going to be on the quiz?
Okay. So if you look on worksheet 2, I think all those topics you're going to see from worksheet 2. Yeah, so you're going to see find a critical number, find critical values. You're going to see extreme value theorem. You'll see a Rolle's theorem. You'll see a mean value theorem. First derivative test, find relative max, min, increase, decrease, concave up, concave down, point of inflection using the second derivative function. Second derivative test to find relative max, relative min, and then sketching a graph.
Can we do a sketching the graph one?
Yeah. This is from the textbook, number 54. So we'll do this one here. I'm just going to copy that down here, 54.
I left my license in the copier. And it's not there.
Oh, really?
So, yeah, because I was scanning it.
1 second. Okay. All right, so first things first, we're going to graph those points, right? Those are easy to graph. Just order pairs, f of 0 equals 0, f of 2 equals 0. The next three statements are giving us information about f prime. I think it's helpful if we can create a slope sine line based off of that. So any x value that you can find, go ahead and put them onto your sine line. Looks like the only x value that I have here is 1. Okay, what does this statement mean? F prime of x is greater than 0. What's another way of saying that?
Slope is positive.
Slope is positive. Where is slope positive?
Greater than 1 when x is less than 1.
Yeah, positive slope here. Okay. How about what's happening here? F prime of 1 is equal to 0. How would you interpret this? F prime is referring to slope, right? So slope at 1 is equal to 0. So we have slope 0 here. Okay, final statement. F prime of x is less than 0 for x is greater than 1. Negative slope to the right of 1. So I think from this sine line we can tell what's happening, right? We're going to get a positive slope up until 1 at some point. We don't know what that point is, but we just have to create some relative maximum, and then we come back down again. So we know our graph will look something like this, right? And then the last statement, f double prime is less than 0. How would you interpret this? What's second derivative referring to? What's it talking about? Second derivative is concavity, right? So negative concavity is concave what? Concave down, right? So it's saying that it's concave down. There's no restriction, so it looks like it's concave down everywhere. So I just know that my graph is going to have a concave down shape everywhere. So maybe I can go back to my graph and kind of update it, make sure it has that full shape. So I like to sketch a graph twice. Once just so I can have some feel for the rise and fall of the graph. And then I can go back and kind of clean it up in terms of the curvature and making it match my second derivative information. Okay. So help session tomorrow. If you want to print out that morning review, you can bring that. Ethan, you want to come in the morning, you can bring that in. We can go through that worksheet as well.
I have a chemistry help session tomorrow morning. I have a test tomorrow for chemistry.
Oh, I see. Okay. But the quiz review, I mean, the morning review is on the website. I made a video of that as well, so hopefully that'll help if you want to work through that tonight on your own. All right. Hopefully you guys have a chance to work through, if you want to rework some of the review problems that we did on between worksheets 1 and 3, and then you also have worksheet 4 as well. Key is included on the website as well as a video. So. All right, thanks for being here.
Thank you.
See you guys. Bye.
Thank you.
See you guys. Bye.